This is Stephen Moy, and Stephen is the lead engineer on our metrics data team. The metrics data team at Yelp builds out our data lake and a lot of the infrastructure and environment surrounding that. I'm really excited to give this talk with him.
Thank you, Zach. And Zach has actually recently changed role. He is now our engineering manager for our infrastructure security team at Yelp.
But before infrastructure security, I was doing metrics infrastructure, which put me almost next door to Stephen. And it's always been a joy to get to collaborate. So we're hoping that this talk is fun and that we can show you the treasure and the map to the treasure. We have to ask ourselves, of course, when we're going on a treasure hunt, what exactly are we looking for? Where can we find some clues that will inform our approach to following the treasure map? Of course, we have to uncover the treasure map before we can follow it. And along the way, maybe we'll find some treasure that we didn't even know we were looking for. Who knows?
Yeah, so we were expecting to understand how our engineers and the company uses those cloud storage platform. The reason being that is if we know how they're using it, then we can lifecycle their data at the appropriate time to the appropriate tiers. And we want to be able to make those decisions based on evidence-based approach, so we'll be able to deterministically call out what data we can lifecycle to. In the beginning, and almost 10 plus years ago, Yelp was very happy to move to the Amazon S3 storage layer because we don't have to worry about running out of space on a distributed file system, no name, no problem. But fast forward 10 plus years later, we have dozens of petabytes of problems.
What is our treasure? You're our treasure. Thanks for hanging out with us this late in the afternoon.
Thank you. So as we mentioned, we store lots of things on Amazon S3. And we really want to lifecycle a bulk of the data into the right tier. Now, we want to be able to make, when should we move those data? Is it a year? That seems pretty conservative. Or for some strange business reason, it has to be 400 days. It's not a unique problem here at Yelp. We believe it actually, many other companies in our industries face the same issue because a lot of our workload these days has been moved to cloud storage. It's really alluring when no one has to go expand those disarray anymore. And the abstraction seems simple enough. We just need to know how to put the key, how to get the key. The caveat would be you've got to afford to build every month.
Yelp's been paying the bill for a long time. We were a pretty early adopter of the cloud. It's coming on 10 years now, thereabouts. And everything's well and good when your cloud infrastructure is in a nascent state, but eventually leadership says to you, why are we spending so much money? Huh? Do we really need tens of petabytes stored in the cloud? That's what the business folks say. They frame it very broadly. Do we need this?
And as a developer too, the intuition is, my jobs cannot be touching petabytes of data all the time. Why would they need to? Maybe terabytes, but definitely not petabytes.
And eventually, we boil that question down a little tighter, and we start talking about something that we can actually model, like access patterns. Do we really access all data equally all the time? A bunch of Apache logs from 2008, are those equally accessed compared to user information that is from last month?
Now, if we only know exactly how our developers are using those data on S3, then we'll be able to make those decisions.
We need a map?
I think we do.
Did you bring your lemon juice?
I have some here.
All right. I guess we're in business. We'll call up Nick Cage and we'll get started on this national treasure hunt.
Let's do it. So our objective, we want to realize large storage savings measured in dollars. Our expectation is if we can save a lot of money, we'll likely end up in the quarterly deck. And it's always nice to get showcased.
And actually, ever since I changed roles, and this was pretty recently, earlier this year, I started thinking about the security implications of this work. And it turns out that they're substantial. So the principle of least privilege, you're probably familiar with it. basically for sensitive data or personally identifiable information, only the set of people and the set of services who need it for regular operations should have access to it. But this is really hard to define if you don't know who uses what data just off the top of your head. So understanding access patterns can make the principle of least privilege, which is never easy, at least easier.
Yeah, and especially when it's time to do those forensics, it's nice to have those access trails. Otherwise, you can only guess based on your knowledge of the existing behavior of our systems. It's nice to not have to guess. Now, in the subsequent examples, we're going to use Amazon S3 for Yelp. But it's very likely the techniques that we use, you will be able to use something similar from your storage provider. In Amazon S3, they have a feature called S3 server-side logging. It's an Apache-like access logs for every single operation on the web service. Now, of course, being S3, if you want to get those access logs, you're just going to be on S3.
OK, so they're there, right? I can just go use them?
Just remember to turn it on.
We have to turn it on?
Yeah, they have decided to be default off.
Oh, no. These are probably really expensive. Amazon's going to charge me an arm and a leg for this, aren't they?
Not exactly.
What?
So actually, this is, they consider free. They only cost you based on the size of the access log that ends up in your bucket. So they are like, kilobytes and megabytes compared to you probably have petabytes in the bucket.
I see. So once we get Nick Cage's data, is he going to, he's going to analyze the access logs, isn't he?
Of course. Let's dive right in.
All right.
So in S3 access logs, they are non-compressed. They are row-based format. They tend to be very tiny. Our observation is between kilobytes to megabytes. Mileage rate vary. The size is really just based on the operation you're doing on the bucket. Now, we have many thousands to even millions of entries per day. And what's this line beneath for us is that you will need a really complex regex to parse it. This is the slice of only one single entry. This is the sample entry from the Amazon documentation.
No.
And you're supposed to come up with a regex to grab all the appropriate columns out. I'll point out a field that is important in our exercise. Now, of course, we will need to get the bucket name, and of course, the S3 key that's being operated on. And you're going to get like when and who access it. But those are kind of our starting point on the journey.
And I have an opinionated opinion to make here, and that is that conversion is a bit expensive. If you're processing data, even if this data is like 1% of the real data that it represents, it's metadata, right? This is still expensive if you're analyzing 5 or 10 years of logs for the first time. And there's no need to repeat that conversion. We may as well store a queryable result. And if you actually want to do science with this, if you actually want to enable other folks to reproduce or replicate your results, we'd better give them some determinism, such as a persistent data store that they can work with without having to rerun an hours-long program.
And we'd like to announce we have open sourced the work that we have presented in these presentations. We figured that if we have this problem, the others in the industry may have this problem. So we have open sourced our code, and we would love for you to check it out and give us some feedback.
Pull requests are welcome. Thank you so much for checking it out. There's really no need to photograph each slide. This is all on our GitHub, and we're going to upload the slide deck there as well.
Cool.
But if Nick Cage has the clues, and if the clues are the floor, then Nick Cage is going to steal your floor, and then you're going to fall through the floor, and then what are you going to do? You're going to cry in the basement because Nick Cage has the Declaration of Independence that was for some reason on your floor.
Speaking of the Declaration of Independence, we're going to present you a block diagram, what we're going to do. So the first block of our diagram is to be able to use SQL to do our analytics. Now, both Yelp developers and our analysts are very comfortable using SQL to slice and dice data. And we figure if we enable this capability against these flag files, we can enable them to iterate really quickly. There are many ways to do it. AWS Athena happens to be the easiest for us. Being in a Spark Summit, I really should mention that Spark SQL could have easily taken care of it as well. But for Yelp, because our Spark cluster tends to be ephemeral, that means that they don't stay up all the time. Once we finish using it, they get tear down. We want to make sure that our analysts would be able to query those data, even though they may not be typically spinning up their own Spark cluster. So we've used Athena since it's on demand. Is just you should query, the endpoint is always going to be available.
So we have a couple of tricks, a couple of clues to get you closer to finding that treasure and completing this analysis with Athena. And one of these basically allows you to sort of do a constant time data extraction. So if you're interested in when a file was written and when a file was read, you could, well, not easily, but you could like parse the access logs going back to 2008 to find when that file was actually put there, and then find all the accesses going forward. And I don't even want to think about the complexity of this and the computational load. So why don't we just have sane naming conventions? Yeah, naming things is hard, but it turns out that at Yelp we have this really nice convention where the vast majority of our data stored in the cloud has the year, the month, and the day embedded. And it tends to be pretty consistent. Whatever your nomenclature is, I encourage you to rely on it because it's really, really, really important. And you can just do regex on the key name. So we can pull out the actual date object and just based on the key. Much easier.
Speaking of nomenclature, we found this meme, and for the eagle eyes of the audience, you may notice that the meme, the text part, actually spell Nick Cage, Nicholas with the H. If you know the actor Nick, his name, he goes by it without the H. So just stick with your nomenclature.
Whatever that may be. So to reiterate and give you another clue, we actually don't care at all when accesses occur. We do care how far in the past the creation of the file is versus when the file was accessed. So why don't we just do that with SQL? Why not? I mean, we have the access logs that show the request time that the file was requested to be downloaded, and we can extract the day that it was written, as I showed you in 1A. So why don't we just stick those together and use the magical date diff function that I didn't know existed before we did this project and get an integer called days apart, and we can filter on that. And one more thing, if you have a big Amazon infrastructure such as we do, what you're going to find is you're going to be playing ARN Bingo, where ARNs are the identifiers that describe a certain Amazon resource. So in this case, what you can see at the end of all these lines is that there's an instance ID. So this is the actual EC2 instance that did the downloading, and they assumed a role that allowed them to do the downloading. In this case, the role is called mrjob EC2. But so I'll give you a clue. These are 10 different ARNs, and they all represent the exact same elastic MapReduce job in this case. And this is because there's dozens or hundreds of different nodes attached to that job, so they all have different ARNs. If we break that cardinality and we strike a middle ground where we say, oh, you know, it's probably sufficient to say that if that MapReduce job accessed that data on that day, that's a good enough classifier grouping for us to work off of. You get more meaningful results, and you get results that you can actually look at as a human and actually analyze and do stuff with, rather than something that is just going to break the analysis tool that you put it into.
Along the same vein, in our case, when we look at our access record, we find there are many, many entries. We talk about millions or even billions of entries. And of course, you know, in order to make actionable decision, you want to be able to distill this information to even more high level. And for us, we really think about who accesses it and also what they're accessing. So in this case, requester is typically our developer or machine user. Not name in this case is actually a column re-extracted based on a regex on our S3 key. Very typically in Yelp, we kind of categorize our different data set, embed that name inside our S3 key. So we're using these 2 dimensions and grouping along with them that give us kind of more actionable information because we're not dealing with so many records. Now, we're going to move on to the next blocks of diagrams. We want columnar files to power our SQL analytics. This is, I'm going to go tell you why we want to do that. And also, along the block, we're going to have to be able to convert those S3 raw access logs into columnar files, and we'll be using Spark and Jupyter to do so. Speaking of columnar file formats, this is a key technology for us to really speed the iteration speed and also analysis speed. In those S3 raw access logs, they tend to be very tiny, and as we've spoken earlier, they tend to be kilobyte size, megabyte size. Those are terrible because you can think about them. This is every time you want to read those small tiny files on Amazon S3, you need to open the HTTP connections, actually then grab the bytes. So oftentimes with such a tiny file, the overhead of opening those connections is going to drop the actual time you spend to CPU time you spend to analyze those files. And in addition of that, columnar files give us this very easy way to minimize I/O access. Now, columnar files arrange their data based on columns versus then rows. What that means is if our SQL analysis only use few of those columns, we are only paying the I/O cost for those columns. If you remember that messy entry earlier, most of those fields we don't read. We don't want to pay the I/O costs. Now, in order to generate this columnar file formats, we have picked Parquet, and we're also going to generate a snappy compressed versions of those Parquet files. The reason we did that is Spark has wonderful support for the Parquet file format, and if you have listened to the keynote, the newly open source project Delta Lake is also based on Parquet. In addition to that, we have a good familiarity of Spark. We know that it can scale, and with millions of entries on these access logs, that's why we've decided to use Spark. Now, there's the next block. We wasn't expecting we have to do this, but we run into a snag when we're just trying to run our implementation. And this has to do with S3 prefix scan. I want to remind our audience that S3 is not a file system.
Say it with us now. S3 is not a file system.
That's right. S3 is not a file system. And I want to give you a little bit historical context. During the Spark evolution, when Spark was first written, it's mostly envisioned to utilize data on HDFS. What that means is that that was the Hadoop distributed file system, and that was a real file system. So when you actually have nested folders, those are directories, and then you can have subdirectory, then you can have actual leaf nodes, and which are the actual files. What we notice is when we point out batch job at the bucket that has all access log, we run into out-of-memory exception. Yeah, this is the dreadful thing that all Spark developers have to deal with when they're like, OK, out-of-memory exception. What do? Just increase more memory? We're going to have a slight problem because with 10 years of access logs in S3 server-side logging, they're actually going to log all these entries on the same flat structure. The only difference is that each key's prefix is going to be the date. So with 10 years of access logs, we now have accumulated millions to billions of entries. Now, what should we do? In the S3 API, they actually have a low-level API for you to simply query some keys based on the prefix. And if you do so, you will be able to skip the process of listing all the files. I will preface that when S3 was first integrated to Spark, because of the lineage of how they designed the HDFS systems, the S3 implementation would also try to emulate those same operations. So let's say you want to have a glob pattern that simply take care of the date. To apply that glob pattern, instead of translating that directly to an S3 prefix scan, and actually list the directory first and then do the pattern matching, which is not helpful in our case. Now, if you're going to use this prefix-based API in S3, I will remind you about pagination because it is very important, and this leads to the next slide.
You know, when this is in our GitHub repo, and I did the code review for this, and I think it's okay, but it also looked really suspiciously familiar to me when I did this. It was like coming back to a place you haven't been to in a long time, and feeling like this sense of familiarity.
Yeah, Zach, that's because I actually have looked at your implementation and lifted it out there and slightly modified it.
And my implementation would have been like 5 years earlier, probably. It was a relatively old project if we're thinking of the same thing.
Yeah, I think we both of us have written this like 4 or 5 times.
Yeah.
But this is in our GitHub repo. You can study it. But the key fact is that whenever you request, you query something from Amazon Web Services, it's very likely the results going to be paginated. Paginated because they don't want the response size to exceed certain like 1 megabyte, or bigger. So what happens is inside the response, you're going to have a continuation token. And you're going to need to use this continuation token to fetch the subsequent results for that very initial response. And if you don't, you'll be only analyzing a fraction of the data that you were originally planning to analyze. Now, we explained you the problem, so we have to give you a workaround. So what we do is, instead of naively using the Spark session.read.parquet and then giving an S3 prefix, what we're going to do is we're actually going to use the Boto API to first do an S3 prefix list. We're going to get a list, and then we're going to turn it into an RDD. And then with this RDD, we can interact with the rest of the data from API. Most of the time, how we are using our conversion batches, we are dealing it based on the date granularity. So we don't run into the same memory pressure when we have to deal with the original implementation where it has to list our billion objects in our bucket. Now, you may wonder why is the reason we structure our solution into a two-step analysis. In this case, we have a self-counting Spark job that simply take the S3 raw access log and then just parqueify it. And then I will spit it back to an S3, and then we use a separate system, in our case, AWS Athena, to analyze the results. It has to do with our recent migration toward having an infrastructure like Data Lake to power our data analysis in S3. We figured there are 2 very important things we want to do in our infrastructure for our data platform. One is we want to have this SQL capability for all our data. Traditionally, Yelp our team also runs a data warehouse. But as the explosion of data growth, we really need a different type of data systems to allow those high concurrency systems. So we have moved toward the data lake strategy. In this case, in the data lake, we have many other different types of files. In our case, because we started 10 years ago, we have accumulated a lot of gzip to JSONs, so we need these SQL capabilities for many different open file formats. Second of all, as we build up the data lake using Parquet, we increasingly wanted to have a lot of tooling to convert lots of different files into Parquet files. And we figure, structuring our solution in these 2 very straightforward component allow us to reuse them down the road.
So there were interesting organizational considerations on this project. In fact, I think we were both pretty confident that the technical stuff would sort itself out as we iterated. But this was a big step for Yelp, the organization, because it's the first time at Yelp, in Yelp's history, that all the data that Yelp has created over the years is not instantly available to any developer or product manager or analyst who wants to work with it. we moved a lot of this into S3 Glacier, which is an archival service provided by Amazon. And Glacier bulk restores take like 12 hours to complete. It's the most cost-effective way to get your data back, and it's actually quite inexpensive. The math works out. You can get it cheaper, faster, stronger. The fastest you can get it is about 15 minutes. That really only works well for small files because it is just that expensive. And so when we said to leadership, like, hey, not all data will be instantly available, but we'll save so much money, and we'll get you this treasure. One of the first things they said was like, well, do we know that that will be okay? And that led us to this analysis. It turns out that the developer impact, we care a lot about developer velocity, and the impact was minor or almost non-existent. Because since we enabled this at the end of last year, there's been well under 10 restore operations that anyone has ever needed to do. And there's an API that you call, and we built a little tool, and so it's not really that difficult. But what is a change in mindset is that you can't just go and decide, hey, right now I'm going to process data from 2009. No, you have to wait 12 hours. So that pushes all of your analysis pretty much to the next day. But if you're processing data from 2009, you're probably also processing 2010 and 11 and 12 and so on. And at that point, this is a massive computation that you are doing. And it's already measured in days. So who cares? Add 12 hours. It's fine. This happens so infrequently that, it makes sense. To give you a little bit of insight into the analysis, like this was the end result of two of our biggest S3 buckets. Initially, everything was just in standard access, the default in S3. And now, as you can see, that is just not the case. We used AWS's pricing data to sort of make this trade-off and decide where to draw the lines. And we can use this access analysis for the total cost of ownership. Infrequent access storage and Glacier storage both have like different pricing structures. So that 20% of the data, it tends to be between 90 and 400 days old. And that means, turns out, that it's very rarely accessed. So S3 infrequent access is still instantly available, but instead of just paying for the storage, you pay every time you download it, in addition to the storage. It's still immediately available. This gives a lot of confidence where if you need to do like a 6-month backfill or something, hey, it's fine, it's still there, no developer impact. That's nice. But half of our data, over 400 days old, is archivable. And that means it's no longer instantly available. We put it in S3 Glacier, so we pay to archive it the first time, and then we pay to retrieve it, which is almost always never, and occasionally is like once. Like I said, we do need to wait 12 hours, and the developers do need to plan ahead. But there is a secret to this slide, and the secret is the 400 days number. Why 400 days? That's a weird number. Well, a really common ask from product and from data engineering teams is for a year's worth of data. But they don't want like April 15th to April 15th most commonly. They want something, hopefully, that's like on a month boundary. I think a year boundary is a little excessive, don't you? But they tend to want like January to January or March to March or something like that. And so, okay, well, let's give them 365 days of data. Oh, but then there are leap years. Okay, so 366. Okay, but like, what if you're in the middle of the month? What if you're on the 15th of the month and you want to have the most recent day of the backfill be like the end of the last month? Okay, so now we need like, instead of 366, we need like 396, 397. Okay, call it 400. Because if I wrote 397 on this slide, you'd be like, that's even stranger. At least 400 is a round number, right? So what do we find? What is this treasure? Total savings to Yelp engineering on our S3 bill, about 25% gone for good recurring cost. This adds up easily into the 6 figures. And I wouldn't be surprised if as the years go on, it comes into the 7 figures. Developer impact, we estimated it at like 20 hours a year across the entire organization. And when we were so worried about getting pushback on implementing this, on making this radical change in how we deal with the availability of data and what guarantees we provide, we were worried about pushback. And then we did the analysis. And then we talked to vice presidents and to the head of engineering and to different stakeholders across the org, and there was no pushback. None at all. Everyone was like, go forth and get us our money back. Because when you write a design document that is, let's say, 4 pages long, 5 pages long, but the TLDR is, please sign this unless you hate money, everybody signs it. It's really convenient.
Yeah, to summarize, what we end up to do is to use Spark as like a sweet army knife. And we wanted to pull all this access logs data into Parquet data. And we're iterating it using Jupyter notebooks. And then finally, we use the Athena as a SQL analysis to analyze our access pattern.
Sounds like a treasure? I don't know. Is that a treasure? Did we steal the treasure? Did you have one more?
No, I think we did it. We did get that pile of gold at the end of the day.
Well, we have cheaper data. We have Spark and Parquet. And most importantly, we have Nicolas Cage. So that sounds like treasure to me.
And we would love you to check out our open source project. We would love feedback. And if you want to put in a pull request, we'd love to hear from you.
Thank you so much for coming out.
All right, thanks, guys. Awesome. So if you have any questions, please feel free to come to the center here and walk on up.
Let me just leave it on that.
Any questions?
So when you say you save 25% of the bucket cost, is it only the storage cost, or does this include the operational cost as well?
I'm glad you asked. This is total cost of ownership. So we did not just save on the infrastructural cost. We also factored in the projected amount of restorations that would be done and approximately how much those would cost over the last 1 year. And we also factored in the engineering cost of having to deal with the lifecycle transition rules.
But I guess my question is, like, does it include, when you project the total cost, does it include the regular operation access for your regular data, or is it like when you calculate the total cost, right? Like, do you include the normal access operation cost? Because it seems like for a lot of the companies, like the typical operation cost for S3 is like almost half of the storage cost.
Yeah, I believe that we included all of that as well. I'm not sure about the other companies, but yeah, to my knowledge, it's all in there. And as the numbers started shaking out like a quarter down the road, like that was confirmed by billing reports.
Hi, thanks for the talk. It's really interesting. I had a question more along the lines of data discovery. So if things are in Glacier, is it any harder to find, or are people like, oh, I didn't know this data was here, or maybe it is here, but I have no idea where to look? I'm wondering if you ran into that issue, or maybe how it might have been solved, or maybe your data lake was very well organized, so it wasn't a problem.
I wouldn't go so far to say our data lake is very well organized, but one nice thing about, even though Glacier and S3 are two separate services, one nice thing they've integrated between the two is, despite your data is now in Glacier, the S3 keys are still available on S3. So what happens is, if you do the low-level operation to do Amazon S3 LS, and that key will appear. Now, you may wonder, like, what happened now we have a data lake. In our data lake, we are using the Amazon Glue data catalog service. We don't run our own Hive metastore, but Glue is just a managed Hive metastore. You can think of it that way. And what will happen is some of those partitions, the partition will point to data that have been glaciarized. And of course, if you're actually going to run the SQL engine on that partition, it's not going to be happy because it's going to error out. I think for that, our data lake is pretty new. I will almost say that none of the partitions that is appear on our data lake so far has been glaciarized yet. I think the strategy that will be taken is that as we transition those partition into Glacier, what we'll do is to actually removing that partition from the data catalog. I think that simply makes more sense. Now, but of course now is like, oh, then how do you know it's there? Since we're exposing our data as a table, the table is not going to be deleted. Simply the partition is not available, and we will be rolling in the same support. Right now, our tooling for developer is they explicitly say, hey, I want these keys to be restored. We will be extending that to like, hey, I want this table with this partition restored.
Yep.
Thank you.
Thank you.
Is that code compatible with other storages like Google Storage, or can I use it, same code?
This is where we would love to hear from you. We at Yelp, we only have tried AWS so far, so we're not as familiar with GCS and Azure, but we believe the feature to be able to get your access log is going to be very similar. Because we don't have a lot of exposure of how those storage services abstract the data, we're looking forward to comments in terms of how we should put the abstraction in there. Of course, there are abstraction like OpenStack, but we think the OpenStack abstraction may be a little bit too much for something like this. But let's say if you're using GCS, like take a look at our script, because in our Parquet batch, really what we're doing is to, there are two parts in the batch. One part is to really structurize how to pull the data up from the raw access log. In this case, we expose it as a command line parameter, like in our case, just an S3 prefix. We imagine with the Spark existing connector system, you will simply point it to either Azure Data Lake or the GCS prefix. The second part will be the format of the analysis. And right now, that's already a single function that is translating your log contents into what we are projecting for the analysis. We imagine with the community's feedback, we can abstract that into, let's say, a storage-specific log format reader. Then we can just project it into a common format to do the analysis.
Yeah, that sounds good. Thank you.
Thank you.
All right, that's it. Thanks very much, guys. Thanks very much.
Thanks for coming.
Thanks for coming.